Back again with questions on velocity time graph. The question says a car starts from rest and it accelerates uniformly for 10 seconds before attaining a speed of 20 meters per second. If it maintains this speed for the next 5 seconds, we have to draw a sketch of a velocity time graph. Use the sketch diagram to determine the uniform acceleration, the total distance traveled, and the average speed. Now maybe I will find the uniform acceleration, then I will ask you people to do the other ones. So let's try and draw the velocity time graph. So if I have the velocity time graph, as we know, looks like this, right? Whereby we have velocity here in meter per seconds and time here in what? In seconds. Now let's follow the motion again. They said a car starts from rest and it accelerates uniformly for 10 seconds. Now, something starting from rest, meaning that it started from this point, this origin, and it accelerates uniformly for 10 seconds. That's the time is 10 what? Seconds. Does it make sense? Before attaining a speed of 20 meters per second, now it attained the speed of 20 meters per second. Does it make sense? If it maintains this speed for the next 5 seconds, now this speed now 20, it maintains it as it moves with that speed for the next 5 seconds. Now for the next 5 seconds, but what's the time here? We have to do that 5 seconds plus 10, that 15 seconds. Hope it makes sense. What's the next thing they said? We have to draw a sketch. Now they never say that the car came to rest. Do you understand? So I have to follow it. So the velocity time graph have to look like this. There will be nothing like coming to rest because they never said it in the question. So I have draw a sketch of the velocity time graph, which is this. I've done that. Then use the sketch to determine the uniform acceleration. Now the acceleration, where did the car accelerate? The car started here and accelerated, right? So I'm looking for the acceleration, which is A. Now remembering the first equation of motion, which says final velocity is equals initial velocity plus acceleration times time. Now, what's the final velocity in this part that the body accelerated? That should be 20 meters per second. Then, what is the initial velocity? For the fact that that body started from rest, its initial velocity is actually 0 meters per second. Now, I would like you to take this as a graph, so that here is 0, when you move up here, the velocity increase. Here is 0, when you move right, time increases. Does it make sense? So the final velocity, as I said, is 20 is equals, the initial velocity is what? 0 plus the acceleration is what I'm looking for. Acceleration times time. Now, as in what's the time it took that car to accelerate? It is 10 seconds, right? So the time we are taking now is 8 times 10. That's 10. I mean 10. So I have 20 is equals 8 times 10 is 10a. 0 plus 10a is 10, is still 10a. So the acceleration will now be over 10 over 10. Cancel, 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 0, cancel. So acceleration is 2 meters per second squared. So I've gotten the acceleration. Does it make sense? It should. Now they asked me to find the total distance covered. Now the total distance covered, the car started from here, moved up here, and went here, right? Now, what shape have I formed? If you look at this thing very well, this total shape was from here to here. That looks like that should be a trapezium. Yes, it looks like that's a trapezium. So I'm having something in this order. Look at the shape. Yes, this is the shape. So if you watch from here to here, it started from here to here and went here. Now, this total shape is actually formed by a right angle triangle and a rectangle. So what I'm going to do is, if I want to do it step by step, I have to find the area of this right angle triangle, then the area of this rectangle here. Now, if I split the shape, which is I'm having a right angle triangle and equally a rectangle that formed the total distance covered. Now, what's the area of this triangle? From here to here, as we know, from here to here is actually from here to here, which is the 20. Now, from here to here, which is from here to here, is 10. I hope you understand. Now, what of here? What is from here to here, which is from here to here, which is still 20. Then from here to here is what? From here to here, what's the interval? 15 minus 10, 5. So the average speed will be what? 20. Now, I have to find the area of this triangle. Now, what's the area of a triangle? Half base times height. 1 over 2 times the base, 10 times the height, 20 over 1 over 1. 2 here, 1, 2 here, 5. So the area of this triangle will be 5 times 20, 100 meter, 100 square what meter. Does it make sense? Now the next one, what's the area of this rectangle? That would be 5 times 20, which will give me 100 square meter again. Does it make sense? Now they will ask us the total distance cover. The total distance cover is actually when you sum the what area, and that will give you what 100 plus 100. That will give us 200 what meter. Does it make sense? So the total distance cover is actually 200 what meters. By what did I do? I found the part the car started and where it stopped, right? Does it make sense? Now I would like you guys to do the last one, which says the average speed. Now, what's the formula of finding average speed? It is total distance traveled all over total time taken. So if you take the total distance, which is 200 that I got, all over the total time. Does it make sense? Have a nice day. Like, comment, share, and follow Kosis Academy. Bye-bye.